Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to be going over how to draw resonance structures. So let's get into this. So first of all, you need to be able to draw a reasonable Lewis dot structure. So our example today is going to be the carbonate. So we're asked to draw all of the reasonable resonance structures and resonance hybrid for the carbonate ion. So here I have a reasonable Lewis dot structure. So if you don't know how to draw Lewis dot structures, go to my videos, and I have plenty of videos where I go over examples of how to draw your Lewis dot structures and going over the steps. So once you do that, you should get a Lewis dot structure that looks like this. And the thing about resonance is that the resonance structures are structures that where the structure is the same for your Lewis dot structure, but the double bond can move around. So it doesn't have to be here between the carbon and this oxygen. It could be between the carbon and this oxygen or this oxygen. So anytime you can have a double bond and move electrons from one place to the other, and still have the structure, the connectivity of the atoms and how they're connected to each other, have that stay the same, but move electrons around, then you've got resonance structures. And so let's use this as an example. So here's our reasonable Lewis dot structure. And here we have the double bond there, but we can move electrons around so that the double bond is somewhere else. So now, the thing to keep in mind is that carbon can only have 4 bonds. So what can happen is you can take the lone pair here and then move and create a double bond between that oxygen and the carbon. But if that was to happen, you'd end up with 5 bonds, and you can't have that. So what's going to happen is that these electrons come in, but then these electrons in the bond, the 2 electrons in this bond, will be pushed back onto the oxygen. So you'll get here 2 electrons. One of the bonds is going to move over or move out, and the electrons there are going to become lone pairs. So then what you end up with is a similar structure. So then here you're going to have let's see, I want to draw this correctly. So you're going to have, oops. So give myself some space. And so in this case, you're going to have the oxygen on top here, going to have 3 lone pairs with a single bond. And then you have a double bond on the oxygen here with 2 lone pairs. And then this one is the same as before. So it's going to have 3 lone pairs there. And you got your 2 minus charge. And so that would be another possible Lewis dot structure that's pretty much identical to this one, except that the double bond is on a different oxygen, is between a different oxygen and the carbon. No, but that's not all. You can still move the electrons around. So, for example, what could happen is these electrons on this oxygen can also move, and you can move an electron pair to create a double bond there. But once again, if you create a double bond there, then that's going to push these electrons back on to this oxygen. So then, if you do that, right? So that those electrons form a double bond. That means one of the pair of electrons in one of the bonds here is going to move and become a lone pair. And so when you do that, make sure I have space, you're going to have another possible Lewis dot structure. So if I draw this, it'll be carbon, oxygen, oxygen, oxygen. And then you've got here, you're going to have the double bond there with 2 lone pairs. And then on here, you're going to have the 3 lone pairs again. Like so. And so, as you can see, that the only difference between these three Lewis dot structures is just the placement of where the double bond is. And where the double bond is just based on like the movement of electrons. And so we call these resonance structures because it looks as if, you can go back and forth between these, right? So anytime you have structures that are similar where you can move electrons around and move the double bond around or move a triple bond around or anything like that, you now have resonance structures that are possible. And so the way we draw resonance structures is we'll have a double arrow between them indicating that that it seems to be indicating that there you can fluctuate between these variations. Now this is using Lewis dot structures. This is kind of the best that we can do, but this is really not what's going on. When we talk about resonance structures, it's just a way of visualizing like what we're talking about with regard to the bond. So, but in reality, we're not, these structures really don't exist in reality. It's not like the double bond is actually moving from one oxygen to the next and so on. It's not like there's a fluctuation or a changing from one form to the other over time. That's not really what's going on. Really, what's happening is that the resonance structures are showing that the bonds here are somewhere between a single bond and a double bond. It's more like a hybrid situation. So if you take the example of breeding dogs, right? So you take one type of dog, you take another type of dog, like a pit bull, and you take another type of dog, you mix it together, you get Rottweilers, or you get these weird combinations of dogs with different characteristics. So when you mate them together, you get a hybrid where you've got a little bit of each characteristic. So of the dogs. So the hybrid analogy applies here because in reality, it's not like I have two single bonds and one double bond at any one point. No, what I get a hybrid. So what I get is a mixture or a hybridization of the double bond with the two single bonds. So it's more like the bond the bonds between the oxygens are equal. Now, right as we draw them, they're not equal. A double bond is not the same as a single bond. Double bonds are shorter, they're more energy. Single bonds are longer and less energy, right? So it's not like I have two single bonds and a double bond. That's not the way it is. I have some sort of hybridization of the double bond with the single bonds such that all the bonds in this molecule are equal. All carbon oxygen bonds are equal. They're not different. So it's some hybridization between a single and a double bond. And the way we calculate that usually is we take the double bond and we take the number of bonds, right? So we have 1, 2, 3, 4, but we divide that by the number of atoms. We have 3 atoms. So if you take the four bonds divided by 3, and then the hybrid bond is going to be 1 1/3 of a bond, right? 1/3 of a bond. So each of these would be something like 1 1/3 bonds, right? And the way we represent that is by what is called a hybrid structure. And so what we do with the hybrid structure is we draw the Lewis dot structure like we normally would. So we got our carbon with our oxygen, right? We got our oxygens here. We got lone pairs like so. Let me draw this in. Okay. And so in this case, we're going to have two lone pairs on each of the oxygens, like so. And then we'll, instead of having a double bond on one of these, we draw a dotted or dashed line for all of them representing a partial bond. So here we have one full bond plus a partial bond. And in this case, the partial bond is 1/3 of a bond, right? So, and then so we represent that as a dashed line, and therefore we represent that all of these are equal in their number of bonds and the strength and all that. So we have equal bonds here. One bond is not different from another, and I should have my 2 minus charge there. And so this is called a hybrid structure, and this represents more closely what the molecule actually looks like. So this is what the molecule kind of looks like in nature. These are all equal bonds, and so we have 3 bonds, no lone pairs, and so this would have a trigonal planar structure and so on. So this is our hybrid structure. And these are the resonance structures for our given ion, carbonate. And so that's it for this video. I hope you enjoyed this video. If this was eye-opening and helpful in any way, then please share the video, tell your friends about it, like the video, hit that like button, subscribe to my channel, make sure you hit that notification bell. And when you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If you have an idea or you have a topic or a problem you want me to go over, then please, by all means, let me know. I would love to do that for you. Thanks for joining me and have a great day.